Morning, happy e-learning day. Today for e-learning, we're going to learn about one-step equations and how to solve them using addition and subtraction problems. So first we're going to go ahead and complete the notes part of the assignment, and then afterwards you're going to practice a few problems along. So first you will fill out the notes on handout 1, and then you will end up turning in your notes to handout 1. So when we're solving one-step equations for addition and subtraction problems, it's like keeping the scales balanced. We want the same amount on each side. So if we look at our first scale here, we have 11 minus some number on the first side of the scale, and then on the other side of the scale we have 6. Well, we want to keep it even. So what would we have to take away from 11 to keep it even? Exactly 5. So 11 minus 5 would equal 6. If we look at the opposite side, or the next scale, we have 4 plus a number, and we want it to be the same as 10. We want it to equal the same as 10. So 4 plus 6 would equal 10. And then if we look at our last one here, we have 3 plus a number would equal 15. Well, we'd have to add 12 to get to 15. Now, in order to figure out what that missing number would be, okay, we have to get the number by itself. So in the equations we're going to look at, instead of having a box there, they're going to have an x there or a y or some other variable. So when we solve the equations, it allows us to find that missing variable. In order to do that, the variable must be alone, or another word for alone. In math problem, we're going to say we're going to isolate it on one side. So when you're isolated, you're alone. To isolate the variable, we're going to use the inverse operation. Now remember when we talked about inverse earlier this year, inverse also means opposite. So the opposite of addition, so let's just write this here, the inverse of addition is subtraction, and the inverse of subtraction is addition. Okay, they are opposites of each other. So when we are solving these, we want to keep those equations balanced, just like we did up above. And then the last thing we're going to do is we're going to check our solution by plugging it back in. So we can use these algebraic tiles here to help us represent what we're looking at, or what the equation is and how we would solve it. So if we look at our first example here, we have the x by itself, so we're going to write our equation. Remember yesterday we talked about our equation is when we have two sides, we have that equal sign. So we have x on this side, and we also have these 4 ones by itself. So our equation is going to be x plus those 4 ones. So x plus 4, because we have 4, equals, then we're going to count how many we have on the other side. So we have 10 on that side. Now we need to figure out what x is. So in order to know what x is, we're going to do the opposite of addition. Okay, so we're going to do subtraction. And I want to do the same thing on both sides. So if I have 4 on this side, I want to take them away because I want to get x by itself. Remember, I wanted to get it isolated, alone. So in order to get it alone, I have to take away 4 of the ones. I also need to take away 4 of the ones on the other side. So how many do we have left? So 6. So x would have to equal 6. And then we can go ahead and plug it back into the problem, substitute it in there like we've done before. And if we do 6 plus 4, does that equal 10? Sure does. So we know we solved it correctly. Let's take a look here at another example. So again, we have x. So we're starting with x, plus we have 2 ones. And it's going to equal 6, because we have 6 on the other side. So we're taking what's written on this side, that goes on the first side of our equation, and then what's on the second side here. Now we have to do the opposite to solve it. So the opposite addition is take away. So we're going to take away 2 of the ones on this side to get x isolated. But if I take away 2 on one side of the equal sign, I have to take away 2 on the other side. We have to keep it balanced. So we take away 2. We now have 4 left. So we can say x is equal to 4. And if we go ahead and plug it back into the problem to see if we did it correctly, 4 plus 2 is equal to 6. So we know we solved for x correctly. Now, x does not always have to be on the left-hand side of the problem. So if we look here, we're now starting with 4, and that's going to equal 1 plus x. And then we have to solve it by doing the opposite. So the opposite of addition is subtraction. So we're going to take away. We want to get x by itself, so we take away 1 from x, which means we take away 1 on the other side. So we have x equals 3. And then our last step is to check it by substituting it in there. So 4 equals 1 plus 3. And we know we solved it correctly because 1 plus 3 is 4. All right, let's look at the back side of our notes here and do a few more examples now with subtraction. So if we take a look here, this time instead of adding 1 or there being positive 1, we now have a minus 1 on the side. So again, we're going to start with our x, and then we take away 1, take away 2. And that's going to equal 4. Now, this one's going to work just a little bit differently because now this time we're taking away 1, so we want to do the opposite. So the opposite of taking away 2 is we're going to add 2. So if we have minus 1 to get it to balance out, we're going to add 1. So then these 2 will cancel each other out. We're going to add another one here, so those cancel out. But again, I have to keep it balanced. So if I add 1 on both sides there, I need to add 1 on both sides here. So now I have 6 total. So x equals 6. And again, I can check my answer by plugging that 6 in there. I'm going to do 6 minus 2 equals 4. And that does equal 4, so I know I did it correctly. All right. So let's go ahead here and take a look at our next one. Again, we have the numbers on the left-hand side. Again, we're just going to count how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 is equal to, we have x minus 1. So again, the opposite of subtraction is addition. So we're going to have to add 1 here. So they cancel each other out because 1 minus 1 is 0. We want x by itself, which means I need to add another one here. So now I have 10 squares. So I'm going to say I have x equals 10. Again, we can check that work. 9 is equal to 10 minus 1. 10 minus 1 is indeed 9, so we know we solved that problem correctly. Now, if we want to solve this without algebraic tiles, you can feel free to add them here. But the other way is just remembering your opposites. So the opposite of subtracting 6 is going to be adding 6. And the way we show that we're doing it on both sides, just like we drew them up here, we drew those algebra tiles. Instead of drawing them out, we can just say that on this side, we're going to add, let me change that over to a pen. We're We're going to add 6 to this side because we know the opposite of taking away 6 is adding 6. But if I do it on one side, I have to do it on the other. Again, we're keeping it even on both sides. Well, if I add 6 and I take away 6, that's going to leave that x by itself. That's our main goal, is getting that x isolated. And then we have x is equal to 18, because 12 plus 6 is 18. And then I can go ahead and check it, make sure I did it correctly. And if I do 18 minus 6, is it indeed going to equal 12? So I know I solved it correctly, so x is equal to 18. And then you could draw it on the number line if you wanted to here. We have 18, 17, 18, 19. All right, let's go over here and look at number 7. So the last one, we did the opposite, which was adding 6. Well, what is the opposite of adding 5? That's right, so taking away 5, subtracting 5. So we're going to minus 5. From this side to get that x by itself. Remember, whatever we do on one side of the equal sign, we're keeping it balanced. We're going to subtract it on the other side. So if we add 5 and then take away 5, that's just going to equal out to 0. And then we have x is equal to 11 minus 5. So x is equal to 6. And I can go ahead and plug that in there and do 6 plus 5. It does equal 11. So I know I got my x correct. So x is equal to 6 in this example. All right, so let's do just 2 more, and then I'll have you guys work on your homework. So again, we look at this one, we want to do the opposite. So if we are subtracting, the opposite of subtracting is adding 2, because we want to get x by itself. That is our whole goal. Okay, x wants to be by itself. So we're going to add 2 to the other side. So we have 15 plus 2 is 17. So if we have x plus 2 minus 2, we know those are going to cancel out to 0. So we have 17 is equal to x. And if we go ahead and, or x is equal to 17, if we go ahead and substitute that 17 back up in there, and we have 17 minus 2, that does equal 15. So we did it correctly. And again, we could put it on here if we wanted to. All right, last example, then I'll set you off to do your homework. All right, so if we have x, the opposite of addition is subtraction. So we want to take away 4. We're going to do that on both sides to keep it balanced. If we have 17 minus 4, that's going to equal 13. It's equal to, and then x plus 4 minus 4, that is going to equal just x. Those x's cancel out to 0 because 4 minus 4 is 0. So x equals 13. And then we can go ahead and check it. Make sure we got x correct. Make sure we did our math correctly. 13 plus 4 does equal 17. So we know we did it correctly. And again, we didn't craft this one up here, but we could go ahead and do that. If you have any questions, please reach out to me. Let me know. You do not have to worry about the last of these examples unless you just want to try them on your own. And you can email it to me and I can check them before you go and work on the homework assignment. The homework assignment is attached in a second assignment on Google Classroom. I will also attach some additional videos if you need additional assistance, help understanding what we did today. But again, feel free to reach out. And then now, once you have these done, go ahead and turn this in. Make sure you turn it into handout 1. Okay, not homework. This is handout 1. These are our notes. So make sure you turn it into the notes section. I hope you have a wonderful day. Stay safe, stay warm, and we'll see you when we get back to school.